Hey everybody! So in my last video, I showed how to use the circle tools. And before that, in the first video, I showed points and lines. So if you haven't watched those videos, please make sure you watch those first. Today, I'm going to show how to use some of these special line tools, and I'm going to explain actually not just how to use them, but kind of why they work. So to get started, we'll take a look at the perpendicular line tool. So this does exactly what you would expect. If I have a line and I have a point, Euclidean geometry says that there's exactly one line that passes through that point C that's perpendicular to this line AB. Well, if I were to try to construct that with a compass and straight edge, I have to go through quite a few steps. So I'm going to show what those steps look like as if I didn't have this magical perpendicular line segment tool or perpendicular line tool. So I'm going to hide my axes and my grid here, and I'm going to give myself a little bit of space. So what we would do with a compass and straight edge is I would grab my compass, I would center it at point C, and whether or not I have points labeled on my line, I would pick a point on that line and I would draw a circle that passes through that point. And then you'll see that I have another place where that circle intersects the line. So I'm going to use my intersect tool to define that point. And so now I have 2 points A and D that are equidistant from point C. Now, the rest of the construction to find this perpendicular line are exactly the steps that we would use to define a perpendicular bisector. Because what we're actually going to do now is we're going to define the perpendicular bisector between points A and D. Now, depending on your, how big your compass opens, that will determine kind of this next step. But essentially what we want to do with a compass and straight edge is that we want to construct a circle that is centered at point A, whose radius is bigger than half of AD. The simplest way to do this is just center it at A and use D as the radius. And then we want to construct a circle that has the same exact radius, but is centered at D. So since I defined my radius to be AD using my circle with center through point tool, I could click on D, then A, or remember our compass tool would allow us to just copy that circle centered at D, right? If I'm using a compass and straight edge, hopefully your compass isn't a collapsible compass. So let me just show that one more time in that I don't necessarily need exactly that radius. So I'm going to pick a point on this line that's, on the line. So I'm going to make sure I've got my hand tool. So I'm just going to move that line E to make sure it's on there. I just want to make sure it's bigger than halfway so that it can intersect. And so basically the idea here, and I'm going to use my compass tool to copy that, is that no matter how big those two circles are, as long as they have the same radius that is larger than half the distance between those 2 points, those 2 circles intersect in 2 places, and those 2 points of intersection define a line. So I showed the intersect tool in my first video, but I didn't show it in the context of a circle. So because these 2 circles intersect each other at 2 different points, if I select one circle and then the other, notice my intersect tool defines both of those points of intersection, which is pretty cool. Alternately, if I just wanted to define one point of intersection, I can do that by clicking on the intersection itself. But here, having both of those is useful for our purposes. So then I've got my line, and this is the line that passes through C that is perpendicular to AB. Now that's not a perpendicular bisector of AB, it's a perpendicular bisector of AD. Okay, so I'm going to go in and delete all of this stuff because the cool thing about GeoGebra is that I don't need all that. So let's see, let me delete all of those things. So if I have line AB, I've got point C, and I want a line perpendicular to AB that passes through C, all I need is my perpendicular line tool. And when I hover over that, oops, it says select perpendicular line and point. So the order here is not important. I can select the line, then the point, or the point and the line. So if this is the line I want a perpendicular to, and this is the point I want it to go through, that's all we have to do. And that is super, super useful. Similarly, let's say I want the perpendicular bisector of AB. I can click on my perpendicular bisector tool and click point A, then point B. And this point H is perpendicular to line AB, and the distance from A to that line and the distance from that line to B are equal. And that is a super, super, super useful tool in geometric design. So cool. So those are our perpendicular line and perpendicular bisector tools. The parallel line tool works very similar to the perpendicular line tool. Euclid's fifth postulate says through a given point, not on a given line, there's exactly one line parallel to it. This is pretty complicated to construct without this tool. What you would do is copy an angle. So let's say I wanted to draw a line parallel to line AB that goes through point C. I would have to say draw a line through point C that meets line AB at some angle, and then I have to copy that angle, which is, no simple thing with a compass and straight edge. So, I draw an arc, and then I want to copy. Well, here, let's see what's going to be the easiest way. There's a bunch of different ways that you can do this, but basically, whoops, I didn't mean to click that. Yeah, so here's one way I could do it. So I can draw circle AC, and then I can copy that distance. So the easiest way to transfer that circle distance is with the compass tool. So if I copy that circle here, and then to copy that angle, what I want to do is find this point of intersection. And basically I want that distance CD, and I'm going to copy that with a circle. So CD looks like this, and I've got that intersection. And so then if I copy that circle to point E, then I have that intersection, and now, woo, I have a parallel line. So that was pretty complicated, right? Thanks to GeoGebra, I don't have to do all that. I can just click on my parallel line tool, say this is the line I want parallel, and then click on the point. But all of those steps that I showed, are what's going on behind the scenes. So this is an exact mathematical construction. So that gets us perpendicular line, parallel line, perpendicular bisector, angle bisector. Again, I could show, let's see, kind of how this works in the Euclidean sense. So let's say I want to bisect angle BAC with a compass and straight edge. Well, I would start by drawing an arc. Okay. And then essentially I'm going to construct the perpendicular bisector of, in this, here I'm calling it CD. So where that arc intersects those two sides of the angle, I'm going to construct a perpendicular bisector. So compass and straight edge, I draw two arcs. Easiest thing is to just center at one, radius the distance between them. But again, as long as it's bigger than half of the distance, you're fine. And here, I really only need kind of one of those points of intersection, although having two doesn't hurt, because the vertex of our angle is one of the 2 points that define that line. So here, this red line is the angle bisector of BAC. So that is angle BAE is equal in size to angle EAC. Again, GeoGebra allows us to not have to go through all of those Euclidean steps. Oops, I lost this. So thing about this tool that you have to remember is that I can either select 3 points with the vertex in the middle. So I could do BAC, or I can do CAB. So those 2 options will give me that angle bisector. Or I can select the 2 lines. Now, if I select the 2 sides of my angle, it's actually going to give me 2 angle bisectors, right? Because the way I have those lines drawn, right, they intersect at point A. So this line bisects that angle, and this line bisects this angle. So if you don't want both of those angle bisectors there, you can't just delete one without deleting the other one. So I strongly recommend having 3 points defined to use to name your angle. If, say, for instance, I didn't have point C here, I can always find some other intersection, or I can use my point on object tool to define another point so that I can name that angle. So a lot of options there. Tangents, this is useful in certain contexts in geometric design. This is probably the last one that I'll show in this video. So Euclidean geometry says, let's see, let me delete you. Okay. So Euclidean geometry says that if I have a circle, so say circle AC, then if I have some point outside that circle, there are exactly 2 tangent lines that I can draw from that point to this circle. So for example, if I use my tangents tool here, I can either click the circle first, then point B, or point B, then the circle. And that's going to construct those 2 tangent lines. So notice if I change the size of that circle by moving point C, the algebraic definitions of those lines change. And what's cool here is that my intersection tool will find those points of tangency. which is nice, and that's a really useful tool in geometric construction. This find tangents tool can also be used, if I have some parabolas or some, well, actually, let's see. Yeah, we won't get into all the parabola stuff. But if I have like two parabolas, I can use the tangent tool to find the mutual tangent to the two parabolas and things like that. But just play around and leave comments if you have questions or if there's anything that you liked or need me to clarify in a future video. I'm happy to help. Thanks so much.